Hi students, today we are going to see the charging by conduction in topic electrostatic. Charging by conduction. Let's assume we have a negatively charged metal object here and an uncharged metal sphere. When we take the negatively charged object closer to the sphere, the negative charges will be repelled to the right side of the sphere and the left side will be positively charged. So when they come in contact, there will be an attraction force between the negative charges and the positive charges. As the negative charges can move and positive charges cannot move, so these negative charges will pass to the sphere. So the sphere will be charged negatively. If the dimensions are known, then we can say that the objects will share the total charge proportional with their dimensions. So, share the total charge proportional with their sizes. So, I have a sphere with a radius of r1 and charge q1 and another sphere with a radius of r2 and charge q2. When they are in contact, then the charge of the first sphere will be equal to the total charge times the radius of the sphere 1 over the total radius. So the charge of the second one will be equal to the total charge times the radius of the second sphere over the total radius. So this mathematical equation tells us that they share the total charge proportional with their sizes. In charging by conduction, objects are charged with the same sign of charge. That means that they are both positive, negative, or neutral. The amount of charge depends on their sizes. The bigger the object is, the more the charge it has. And the total charge is always conserved. The total charge before the interaction is equal to the total charge after the interaction. Let's do an example. We have two spherical objects K and L. They are in contact. When they are separated, what will be their final charges? So here you see that the total charge is equal to minus 5q plus minus 3q, which is equal to minus 8q. It has the radius of K 3r and LR, so the total radius is 4. So the new charge of K will be the total charge times 3 over 4, which is equal to minus 6q. The rest of the charge, which is equal to the total charge, it has a radius of r, so it will take 1/4 of the total charge, which is equal to minus 2q. Now you see again that the total charge is equal to minus 2q. That means that the charge is conserved. In this example, for switch 1 is closed, open, and then switch 2 is closed and open. What will be the charge of each sphere? First, if I close the first switch, then K and L will share the total charge. The total charge here is equal to minus 8q because L is neutral. So K will take the 3 over 4 of the total charge, which is equal to minus 6q, and L will take the rest of it, which is equal to 1/4 of the total charge minus 2q. Now these are, L has minus 2q charge and K has minus 6q charge. Now I have open it, the first switch, and close the second one. So L will touch to the sphere M with its new charge. So here the total charge will become plus 6Q. So L will take, it has a radius of R and M has a radius of 3R, so it has a total radius 3R. L will take the total charge 1 over 3, which is equal to plus 2Q, and M will take the rest of it, or will take the 2 over 3 of the charges, which is equal to plus 4Q. So the final charges of the spheres will be K has the final minus 6Q charge, L has the final plus 2Q charge, and M has the final plus 4Q charge. The given conducting spheres are attached to each other. What will be the charge of each sphere when they are separated, and how many Q of charge pass from which sphere? Now, the total charge here is equal to plus 3Q. So, the new charge of X will be equal to the total charge times, it has a radius R, so the total radius 3R, so it will take 1 over 3 of the total charge plus Q, and Y will take the rest, or 2 over 3 of the total charge, equal to plus 2. In B, how many Q of charge pass and from which sphere? The X, the initial plus 4Q and becomes plus Q, so that means that it has taken minus 3Q of charge. Take from who? The sphere Y. So I could say Y gives minus 3Q charge to X. Here don't forget that negative charges move, but positive charges do not move. This is very important. In this example, K, L, M conducting spheres have charges given. L is first touched to K and is separated and touched to M. If the final charge of M is minus 2Q, what is the initial charge of L? In this example, we are going to solve it from N to initial. So first, examine the touch of L to M. L has a radius of 3R and M has a radius of 2R. The final charge of M is minus 2Q. As they share the total charge proportion their sizes, 2R has the charge of minus 2Q, so 3R has the charge of minus 3Q. So the total charge is equal to minus 5Q. As charge is conserved, the total charge again should be equal to minus 5Q. The charge of M is plus 4Q. So in order to be the total charge minus 5, then the initial charge of L should be equal to minus 9Q, because minus 9Q plus 4Q is equal to minus 5Q. So this minus 9Q is the charge of L after touch to K. Now come to the initial situation, K touch to L. K has a radius of R, L has a radius of 3R. The final charge of L is minus 9Q. Again, as proportion to their dimensions, 3R has a charge of minus 9Q, so R has a charge of minus 3Q. So the total charge is equal to minus 12Q. So initially the total charge again should be equal to minus 12Q. The initial charge of K is equal to plus 8Q. So what should be the initial charge of K? Plus 8Q plus QK should be equal to the total charge minus 12Q. So, sorry, not K here, L. So L has a charge of minus 20Q.